Hey everyone, it's Nick. Welcome back to another duality repair video. Tonight I have a power amplifier for repair. This is an NAD C272 dual channel 150 watt per channel power amplifier. This thing is in really nice shape cosmetically, only a few small blemishes on the top of this front faceplate here. Other than that, the rest of this thing is really nice. But of course I bought it for parts of repair, so that is what I will be working on. The complaint from the previous owner is that there is a distortion on the output. They were not specific to if it was both outputs or if it was left speaker, right speaker, or what. So we'll have to figure that out. So we'll start out by powering it on. I do have it plugged in. As you can see by the standby light, that's on. That's a good start. So I'll turn it on. And that looks good. It's in bridge mode, which is interesting. I guess I didn't think I had it set in bridge mode. I don't have it wired that way, so I'll have to take a look at that quick. Alright, so the bridge mode switch in the back was set to bridge mode, so obviously I switched that over and the bridge mode LED is off, so that's good. I will start with some copyright-free music from YouTube, so let's get that going right now. Start off at a really low volume and I'll slowly turn it up and we'll make sure we at least have an output and check for distortion. Yeah, so maybe you can hear that. I can definitely hear it. It definitely sounds distorted. Now, I'll be honest, the speaker I have is garbage. I bought it at a flea market, really, and so I'm not expecting it to sound great, but I have heard it sound good with other amplifiers, and this is not good. So the next thing I will try is putting a sine wave through it, just maybe a 1 kilohertz sine wave, and then checking it out on the scope. That'll really be able to allow us to see the distortion if there is any. So let me get that set up and we'll go to the scope. Alright, I have my scope hooked up to one of the outputs on the amplifier, and I'm going to put in a 2 kilohertz sine wave. So let's take a look. So there you can see the sine wave start to form as I turn up the volume. Obviously I don't have the speaker hooked up. Now it should be really apparent what's going on here. You can see the peak of the wave looks okay. It's obviously fluctuating. That may be an issue with the input signal, or maybe even my scope, but you can see the trough or the lower portion of the wave is not there. It's clipped basically, and that's not anything to do with the scope. Obviously I can raise and lower, and that's still cut off at the bottom. Doesn't look good. So let's see where that starts to come back. As I turn the volume down, it starts to look better at lower volumes. Right, so it looks like a decent sine wave at the bottom, but this is like 2% of the volume we'd normally want. Even right here is not even close to the volume you'd normally be putting in, and really the trough of this wave looks terrible, and then the peak as well looks pretty bad. So this on its own makes it pretty evident that there's a problem, but it'll be even more apparent if we monitor the input signal and overlay it with the output signal. So to do that, I'll take the cover off and I'll put my channel B probe on the input signal, and we'll monitor the input and output at the same time, and we'll see what the difference is. Alright, I still have channel A of my scope hooked up to one of the outputs. I've now hooked up channel B to the input, and I'm going to put the same 2 kilohertz sine wave into the amplifier, and we will compare the signals. So here we go. I'll start turning up the volume slowly, and so you can see the top, or channel A, is the output, as we can still see a signal. We can already see a signal compared to the bottom, and I'll increase it until we start seeing a little bit of distortion, and we can already see it doesn't look very good on the output there. So there we go. Again, I have my output on the top channel, or channel A, and the input is channel B, so you can see very clearly the difference The upper peak looks okay on the output. Definitely a little more narrow than the input, but the bottom peak is where our problem is. So we're cutting off our signal here at the bottom versus our input, which is a nice clean trough, and that's what we want the output to look like. So there's our problem right there. If you're wondering why the input signal is the same amplitude as the output signal, it's just because I have my volts per division cranked down so we can actually see the wave. If I match them, that's what the actual input signal matched to the output signal is as far as volts per division. So if I put it back to 0.05 volts per division, that's what we get. So I'm going to use this, kind of take this image or remember this image, and this is what I'm going to use as a baseline. So I want my output to match this as far as its characteristics, and obviously right now it's not doing that. So next we'll take a look at the inside of the unit itself, and then we'll probably go after the schematic. We'll go over that really quickly, and we'll try and identify a path to troubleshooting this thing, so fault finding. So next, let's go take a look at the unit. Okay, here's the inside of our unit, and as I said before, really dusty. A lot of buildup. I can wipe my finger pretty much anywhere and get a whole pile of dust. There's also a bit of fuzz and a whole bunch of like cat hair, some sort of hair, all around the unit. So the previous owner must have had a cat or something like that. It was hanging around this thing. But anyway, that's easy to clean up. It's a really nice and clean looking design, so I'm very happy with that. I can go over it pretty quickly. So over here on the right, you can't see it, but right behind this relay is the input back here. And this is all one board here. They call it the, what do they call it? They just call it the power board. And so you have your input coming in there, and obviously we have these big capacitors for the final output filtering. We have our two bridge rectifiers here to create some of the voltages that we'll be testing. And then we have our outputs here. So you can see our 2 channels for the outputs. As far as power, our AC comes in over here on the left, hard to see, but right here. And if we follow it all the way back, it goes to our standby board right here. You see the small transformer. It's a standby transformer. And so when we push the power button, the standby tells the rest of the supply to turn on, and so that's going to send a signal through our power board, and we'll apply power through the transformer, and we'll power up the whole unit. And then obviously right in the middle we have this giant toroidal transformer, which gives this most of its weight, other than the 2 heat sinks here on the side. And so you have 2 vertical boards here, one for the amplification of each channel. So I believe this is the left and this is the right, or vice versa, it doesn't really matter. That's pretty much it for the unit. I've done a little bit of a visual inspection, just to look for anything obvious. I haven't seen any blown capacitors, at least none with their tops blown or bulging. I do already see a few problems, so yeah, you might be able to see it, probably not quite yet until I zoom in. So there you go, you can probably see it now. If you take a look in between these 2 capacitors at the base, you can see down there it looks like the one or both of them maybe have leaked out, but what I think that is that glue, because you can also see it here at the base of this, whatever this is, diode or transistor. There's no capacitors in that area, and you still see that gunk. And I see a whole bunch over here too, maybe not a whole bunch, but some over here. Can't really get it on camera there, but it's there. So that is definitely an item of concern, but not necessarily the cause of our failure. So that's the unit right there. Next we'll take a look at the schematic. Probably start by testing voltages and making sure we have the proper voltages. But let's start by looking at the schematic. So here's a look at the standby board on the schematic. We'll start here with power, AC power coming in. Comes in through that standby transformer that we saw. It's rectified and creates a standby, looks like 5 volts. So when we depress the power switch, it'll enable the output, which will activate the rest of the circuit. Here's our main toroidal transformer here on the right, and the outputs of which will go to the main power board. So that main board on the bottom, and it'll go through. On here it's got 4 rectifiers, 4 bridge rectifiers. I only saw 2 on our board, so I'll have to take a closer look, but it's not a concern right now. But so we have our outputs from the transformer going through at least 2, but maybe 4 bridge rectifiers, creating the voltages for the rest of our circuit. And then, sorry, I'm on the computer, so I have to kind of zoom in and out and slide left and right to make sense of all this. I could print it out, but the resolution just wouldn't be there, or it would just be so small it would be illegible. So the output from our bridge rectifiers will create our voltages, some of which will lead to our output. So here are some of our output capacitors. There are only 4 on there on the board, as you saw. There's 6 labeled here. I think this schematic works for several different versions, so the C270 and the C272 as well, which the C270 may incorporate more capacitors. And then finally we'll get to our output here. So you can see our output binding posts. And so from the transformer, we're going to create several voltages, as I said, DC voltages. You'll see out of the bridge rectifiers here, we have a plus 64, minus 64. I think if we go down here, we have plus 18, minus 18, plus 68, minus 68, plus 34, minus 34. Something like that. So what I really want to start with is, if we scroll up here, we see we have our 2 amplifier boards, so one for the left channel, one for the right. They obviously are going to be identical other than, their polarity. So let's just take a look at this left amplifier board, left channel amplifier board. What I want to start with is take a look at the rail voltages. So plus and minus 64 volts is what's going to be driving the power transistors on these boards. And the same goes for the right board as well. Plus 64, minus 64. And that's going to be really easy to test. I'm just going to find this connector CZ707 and CZ708, and then put my ground probe on chassis, and then probe each of these pins and look for plus and minus 64. And that's a good place to start, so we'll start there. So here we are back at the unit. I have it plugged in but not powered up, and so since we have the plus and minus 64 generated from the same source, I really only need to check the input to one of the channels, so left or right. So I've disconnected this. This is one of the connectors to the left channel here. And so I'm going to turn it on, and I'll probe each of these. And again, I'm looking for plus and minus 64. So I'll turn it on. And here we go. And I'm in the 200 volt range. 69, positive 69, really positive 70 on one pin, a little high, and minus 70 on the other pin. So they are equal. Let me just double check that. Make sure it's supposed to be 64. Let's say 64 on the schematic for these connections, so seems a little high, but I don't think that will cause an issue. So we'll take a look again at the schematic, and we'll check for some other voltages to look at. Okay, so I decided not to check the rest of the voltages. I don't think this is a voltage related issue. And I thought it'd be more exciting to start probing along the signal path to try and determine where our source of the issue is. So I will show you the signal that I'm getting on the scope, and I'll also display the schematic and where I'm probing at each point. So let's go ahead and start at the output of the buffer circuit, which is the input to both left and right amplifier boards. So let's go ahead and start with that. And forgive me, I can't really see if, polarity wise, I don't know if this is left or right. So I'll just go ahead and start with one of the boards here. Obviously I should power it on. Powered on. Good. Turn the signal on here if it's not already. Okay, alright, now we're ready. So here is channel 1, I don't know, left or right. So that looks like a good wave. Let me quick turn up the volume a little bit, or the input signal, just to make sure we're not so low that we're not missing an issue. So here we go, I turned it up a little bit. Yeah, it still looks good. So again, we're getting that bottom trough. It looks like it's identical to the top trough. It's very good. And let me try the other side. So channel 2, again, I don't know if it's left or right. Where's my pin here? Hard to tell. There we go. Same thing. So outside of this buffer circuit here, we're looking good. Going into our amplifier board. So it's not the buffer circuit. So I'll decide now where I want to probe next. I'm now just going to check the output of each channel, and really this will isolate it to an individual board or boards. So here is one channel, so I can get my probe on there. It's tough. There it is. So obviously we have a problem, so that's one channel. Let me check the other channel again. This is the output. Yeah, same thing. So it looks like, since we've checked our input to each channel's amplifier board and the output, and we're getting the same results from each, it looks like each have failed in the same way. So I guess the best thing to do would be to take a look at one board in detail and try and identify what may have gone wrong with that, and trace the problem out on that board and try and verify that the same problem happened on the other board. So next, if I can, I'm going to remove one of these amplifier boards, one of the channels boards. I'm not sure how the power transistors are mounted. If they're soldered into place somewhere, I'm not gonna go ahead and remove that. I'm just gonna have to inspect it in place. But I'll do the best I can, and I'll be back when I figure something out. Thankfully, NAD made it very easy to remove these channel amplifier boards. I was able to remove the right channels board here, and if we zoom in, see something very easily. You can see this electrolytic here looks to have leaked his guts all over the board. So that could be one of our problems, or the only problem. I looked at the other board, the left channel's amplifier board, and the same capacitor has leaked as well. So I'm willing to bet that this could be our issue. You'll notice that it is the largest electrolytic on the board. There's only, maybe 6 electrolytics in the first place, and this is by far the largest. If we take a look at the schematic, let's see, this is C272. So if we take a look at the schematic for the left channel's board here, the amplifier board, we'll see that this is filtering, looks to be filtering our input signal. And so if this has leaked, if it's got high ESR, this could definitely cause the distortion that we're seeing. So what I'm going to do is remove this board, well, isolate it, separate it from the heatsink. Doesn't look like it'll be too bad. It's got one screw here. And then of course I'll have to remove all of these screws for the drive transistors, and then these 2 screws here, and they should separate, and we can take a look. I'll remove this capacitor. We'll check the ESR. I'm willing to bet that it's extremely high, and if so, we'll replace it. We'll clean the board up. Might as well check the ESR for the rest of the electrolytics, but this could be our only issue, and I hope I have a spare. I think this is it's hard to tell what the value is. 2200 at 6.3 volts. I believe I have a spare one of those. We'll see. First things first, though, we'll remove this from the heatsink and we'll take a look at the capacitor. Alright, so it was easy enough to remove this board from the heatsink. And so I removed the capacitor, and here it is. You can see all that goop on the side. I don't think this is glue. I'm not 100% sure, to be honest. Kind of seems like glue. Hard to tell for sure. Whatever it is, it doesn't look good. I did check the ESR, and it actually checked out okay. So this is a 2200 microfarad at 6.3 volts, which should have a maximum ESR of 0.1. And so we're at 0.05 ohms, so half of the rated ESR. Now that doesn't mean that the capacitance hasn't gone out. I don't have a capacitance meter right now, so I can't really check that. I do have a replacement capacitor. Of course, this is a lot larger. This is 2200 microfarads at 35 volts. That's all I have. I want to keep the capacitance the same. Increasing the voltage rating is not going to be a problem at all. So it'll fit inside that board just fine. I'll have to keep it up, raised away from the board just a little bit, just so it's not making contact with that resistor sitting there. We might as well check the ESR on this. So this is 2200 at 35 volts. So it should have a maximum ESR of 0.07. So let's see what this is at. .01. Looks good. So I'm going to install this. It's worth installing and then reinstalling the board to test it out. It's it's, I don't know, 15-20 minutes of work. If that's not it, we'll have to come back to the board, to this board, and take a look at what else might be causing the issue. I'm going to start with this though. I think it's a solid starting point. Alright, so after reinstalling the board, no luck. We still have the same output, as you can see. So what I'm going to do now is try and rule out portions of this circuit. And I'm going to start right in the middle there. So I'm going to look on either side of R328. That pretty much splits the circuit in two. So I'll look on one side here. Alright, we're bad here, and we're bad on the other side. Okay, so that's good. So what that means is that since we have a good input at CZ301 here on the left, and we have a bad signal, or at least the distorted signal here at R328, then our problem is going to be somewhere here on this left part of the circuit. And so we're narrowing it down, which is good. It's interesting that that capacitor that we replaced, C306, is in that part of the circuit. So I wonder if that still has something to do with it. Not the capacitor, but maybe some of that electrolyte that leaked out. Could be causing havoc somewhere on that board, or there could be other problems. So let's see, I'll probably try and find some more places to probe on that section of the circuit. Continue to narrow it down to hopefully one or two components or whatever the problem is. So here I have a portion of the relevant circuit that we're looking at. This is basically half of the left amplifier board. And you can see our input over here on the left, and I cut it off here on the right just so I can zoom it in better, but really this is only half of the amplification. But with the scope, I've narrowed it down so we have a good signal all the way up to this point, and we have a bad signal starting at this point and beyond. And so really our problem is somewhere in between these two. It's a very small section. And so as I was looking at the schematic, I was thinking, well, what are the odds that one or several of these components within here failed on the left channel and the same component or components failed on the right channel to cause our distortion to be the same on both channels? Seems highly unlikely. So I thought, well, what else might cause that? And that would be voltages. So you'll see up here at the top, it's hard to see, but that upper rail is the positive 68 volts and the lower rail down here is minus 68 volts. And obviously that's directly where we're introducing these voltages. And so, of course, earlier on I said, well, I'm not concerned with the voltages. I checked, I think 64, and it was close. They were at 70, plus and minus 70, and I didn't check the rest of the voltages. Definitely a mistake on my part. So I did check these voltages, and I'll show you what I found here. All right. You see these, oh, you can't see them quite. You see these three probes here, black, red, and yellow. These are probes leading off the test points from the board, that test points for the plus and minus 68 volts, one being ground. And so let me show you what I found here. Black, I believe I put as ground. That would make sense, right? And red, I believe, is positive 68. Power it on. And so you can see, can't see the decimal, but 68.6. Good. Very good. Carefully remove that. Don't let it short. And put it on the yellow, which should be negative 68. Aha. Nada. Nothing. So that's our problem. Let's go back to the schematic. So we should have minus 68 volts here. That's going to give us the lower half of our waveform, the amplification for that lower part of the waveform. And it makes perfect sense for why the lower part of our waveform is distorted in the scope, right? So I've also printed off the relevant portion of the power supply here. First, it's upside down. There we go. And so what I don't show here, just because it's really far away, is the bridge rectifier up here, which supplies the plus and minus 68 volts. So all it's missing is a plus and minus 68 volt rectifier. I highly doubt that that's faulty, because we do have our positive 68 volt rail. What we're missing is our negative 68 volt rail. So anything in this path is suspect and could cause the issue. Obviously, we have a bunch of filter capacitors. If any of those have shorted, that's going to cause an issue. We have this series pass transistor. If that's faulty, that's going to cause an issue. A whole bunch of things. Almost any of these components can cause our voltage to be at the near zero that it's at. And so I did a little bit of searching around the board. I did find the bridge rectifier in question, and I searched near that component, and I'm pretty sure I found the issue. So what I'm going to have to do, I'm going to remove this right channel board. And just because the issue is on this main board here, and it's pretty much covered up by this. So I'm going to remove this, and I'll show you what I found. Okay, I removed that right amplifier board, and I have it zoomed in on the power supply section of the main power board. And specifically, you're looking at the plus and minus 68 and plus and minus 64 volt rail circuitry. And so I believe the way they have it is lined up is everywhere from here and back is the plus and minus 68, and then from here and forward is plus and minus 64. So obviously what we want to focus on is this section. And I don't know if you can see it, but there's a couple issues I can see already in our section. Obviously, you can see all of this gunk. I really can't tell, but I think this is glue, because they got some over here by this, I think this is the series pass transistor. They got it. It's all over the place. It does look like, you know, really old leaked electrolyte, but that didn't seem to be the case on the amplifier board where I removed the capacitor. I think that was glue. But you can see that it looks like a mess down here. So it's kind of hard to tell, but this resistor looks cracked. I think this thing is probably wide open. These two might be compromised as well. You can see they're really dark. They may be shorted or wide open as well. And really the most surprising thing is this right here. So it's hard to tell what this is, but it is an exploded capacitor. So it's an electrolytic capacitor that just, I don't know where the hell the rest of it is, because I don't see any remnants, but it's, you know, the aluminum, outer aluminum can or shell is, it seems to be gone. Alright, the new components have arrived. I just need to clean off the excess glue here in the unit and install them, and we'll be ready to test. Okay, time to test it out completely. I have my output hooked up to my scope here. I'm going to power it up and put that same 2 kilohertz sine wave in, and we'll see if it looks a lot better if we get that bottom peak. Alright, the unit's on. I'm going to turn it on and slowly turn up the volume. I do have it hooked up to my speaker as well, so you have to forgive the annoying 2 kilohertz pitch there, but I want to play some music after this, assuming this works. Here we go. You can hear it already. Okay, let's change the trigger level. Yeah, we got it. Super annoying. I'm going to turn that down. I'm just going to start playing some music. You can see the bottom part of our wave is complete now. It's no longer cut off. We have that minus 68 volts. So I'm going to play some music, make sure it sounds good. Yeah, that's better. Perfect. So this one is done. Sounds really good. Let's play a little bit more of this and make sure it still sounds good. Turn up the volume a little bit. Alright, so this one's complete. Thanks for watching. Please subscribe if you haven't. Give me a thumbs up if you liked it. Give me questions or comments in the comments, or send me an email. And I will see you on the next one. It'll be real soon. Thanks for watching.